Hello all, my name is Sai Srinivas Guttulam, and here in this video I am going to speak about Android, and this is my agenda. Actually, speaking about history of Android, it was developed by Andy Rubin and three others in Palo Alto, California, USA in the year 2003. It was later owned by Google in the year 2005. Now that we have seen the history of Android, let us discuss what Android really is. Android is a mobile operating system which is primarily developed for touchscreen devices like smartphones and tablets. Its main feature is that it is an open source operating system. The Android operating system came into use since 2008, and from that time there are 14 versions of it till date. If you observe these versions, there are two interesting features about them. One of them is that the names of the versions are in alphabetical order, and the other is that these versions names are. Now that we have known something about Android, let us get into the architecture of it. Android operating system is divided into four layers and one sublayer. They are Linux kernel, libraries, Android runtime, which is a sublayer, application framework, and finally, seeing the figure, we can find that the topmost layer is the application layer and the bottommost layer is the Linux kernel. Now let us go into the details of each layer, starting from the bottommost layer, which is Linux kernel. Actually, speaking about history of Android, it was developed by Andy Rubin and three others in Palo Alto, California, USA in the year 2003. It was later owned by Google in the year 2005. The layer above the Linux kernel is libraries. Actually, it is the libraries that contain the code that gives Android operating system's main features. Some of many examples of libraries include SQLite library, which is of a lightweight relational database that can be used for storing the data of an application. There is also a WebKit library which enables the browsing of internet. There are many more examples of libraries which include Media Framework, OpenGL, etc. In the same layer of libraries, there is a sublayer called Android Runtime, which provides some of the core libraries that enable the application developers to do their programming in Java. It is these core libraries that provide the functionalities that Java's core libraries provide. This layer also has Dalvik Virtual Machine that allows the applications to run in the process allocated to it in its own sample Dalvik virtual machine. Actually, the Android applications are compiled into Dalvik executables, and as they are specifically designed for battery operated devices, and the layer above the libraries is application framework. As all the applications are written in Java, this layer also shows the application developers the things the Android operating systems can do so that they can make use of these in their applications. The examples of the core applications provided in the Android operating system are email client, SMS program, browsers, maps, contacts, etc. The one above the application framework and the topmost layer of the Android architecture is application layer. This layer has the applications that come with the devices when they are shipped in the market. This layer also includes the applications that are downloaded from the market. It even includes the applications that we develop. Having known with the architecture of Android, let us get known with the application components of Android. For developing an application in Android, we must know the basic components of it. They are activity, broadcast receivers, content provider, and services. The activity is the visual interface between the user of the application and the application. The broadcast receivers are the ones that put an eye on the broadcast announcements and react to the particular events. The examples include a call receiver. The example of call receiver broadcasts the information that the call is being received and asks what to do, whether to accept it or to reject it with a message or just to reject it. The next one is the content providers that allow the exchange of data between the applications. There is an example of contacts, call logs, etc. that exchange the data of the contact information between the applications like WhatsApp and messages. The last one is the services, which is a special component that doesn't require visual interface. These basically run in the background. The examples include the music player and downloading of a file. Having seen the components of Android applications, let us see the activities lifecycle. Initially, when the activity is started, the method known as onCreate is called. It is followed by onStart method to start the activity and then the onResume method to bring the activity to the foreground. After the onResume, the activity would be in running state. If another activity comes in the front of the previously running activity, then the previously running activity would go into onPause state by calling the method onPause. The activity in the pause state comes to the foreground by triggering the onResume method. While the onPause method of the activity is an action and the other application needs memory, its process is killed and the user navigates to the activity of the application that needs memory. When an activity is on pause and is no longer visible, then it would be calling the onStop method to stop the activity. While in onStop method, if the activity comes to the foreground, it calls the onRestart method, which would in turn call the onStart method. While an activity calls the onStop method and meanwhile the other application is requesting for the memory, then the process is killed and the user navigates to the activity of the application needing the memory by calling onCreate method of the application that needs memory. But if the activity is no longer available, it gets destroyed calling the onDestroy method and the activity is shut down. Having seen the activity lifecycle, let us also see the application lifecycle. Each application will have a process and the application is allowed to run in its own process. The activities of the applications are run in the same process. The processes are started or stopped as the application components need to run them. If the resources are needed, the processes are killed and the resources are reclaimed. The applications that are killed may be restored to their last state if the user requests them to be loaded. Now, let us see the future of Android from Seeing the features of Android, one might be impressed to use the Android operated mobile phones. But there are some of the limitations which Android has. Unlike the Symbian mobiles or the phones with Java, the phones that run with Java, the Android consumes large amount of battery. Android also has some security related issues creeping in. As, as this is an operating system for smartphones, one must be always connected to the internet, which is not possible for many users. Having seen all the features and limitations of Android, we hope to see that it conquers all the limitations and wish that this would be developed for the personal computers too. Thank you for making time to watch the video. Hope you all enjoyed it.